All right, working with our first lesson here, our solving equations flip book. You should have already cut this little piece off right there along that dotted line. Cut that piece off. And then we will put together our flip book. You want to fold it down so that these two words line up in this way. So you can still see them both, and it kind of makes like a little tab here. And then we move that one up, so now we have 3 of them. Fold it down. And then the last one. Fold it down. There we go. So when you're all done, you want to color this all up, use highlighters, whatever it is you want to do, you are more than welcome to. So for this one, I am going to go a little faster through the first few parts of these problems because 1-step, 2-step, multi-step equations, these should all be pretty easy for you. So even if you want to sit here and pause the video, go through, do all of the problems, and then you can come back, unpause it and go back and check your answers, you're more than welcome to do that as well. But what we're doing, goal of solving equations is to get the variable by itself. So you have the variable on one side equals your answer. So we do that by using our inverse operations. So our inverses would be adding and subtracting our inverses, multiplying and dividing, and then squaring and square rooting are the inverses that you would have learned about so far. And by inverses, what we mean is one undoes the other one. Now, we don't always show this step. So like, for example, this first problem here, I know I'm going to subtract 9 from both sides. So 3 minus 9 gives me a -6. I'm just not always going to show that step. We want to become more fluent with these problems, which means we want to become quicker. Writing that step isn't very quick. So for here, I'm going to add 2 to both sides. So I get f equals 13. Here I'm multiplying -4 times z. So I'm going to divide by -4. That gives me -12. This one throws people off a little bit. Here we're dividing. It's m divided by -3. So my inverse of dividing would be to multiply. So 9 times -3 gives me -27. This one, you want to flip that fraction and multiply. I will show that one because that one isn't as common. You flip it and you multiply. So 10 times 6/5 gives me a 12. So same thing here. I'm going to multiply by 4 over -3. So that's going to give me a -12 equals y. So go ahead, pause, solve these next ones, then come back and check your work. There we go, -2, -12, 63, and 1/6. Going on to our 2-step. So here we're going to have 2 steps. Again, I'm not always going to show my work for it. So I'm going to add my 4 and then divide by 4. Here I'm going to add my 7 and then multiply by 3. Add my 1, divide by 7. Subtract my 4, multiply by 3. This one, because the y minus 13 is all on the top, I'm going to multiply by 8 first. So that's going to give me 112. Add my 13, so I get 125. Multiply by -3, subtract my 6. These are like terms. They both have a y to it. So I'm going to add my y's first and then divide by my 11. Same thing, combine my k's, divide by 8. So our two-step equation just means that you have two things that need to happen. Next one, multiple steps. Solve multi-steps equations by first isolating the variable. That's always your goal. You always want to isolate that variable. So that first one, we want to get x by itself. Second one, we want to get c by itself. I'll zoom in a little bit more. So we have some like terms to combine here. So I'm going to give me 22x plus 14 equals 80. Subtract my 14, divide by 22, and we get x equals 3. Same thing, I'm going to combine my like terms, add my 8, divide by 4, and we get 1/2. We want to leave this as 1/2. We don't want to do 0.5. Generally, we keep the fractions because fractions are what we call exact value. Now, decimals that terminate like 0.5 are also exact value. However, there's decimals that are not exact value. Like, for example, 0.3 repeating. You can't always write out the full repeating, so you end up rounding. So that is no longer exact value. We want to stick with exact value. We're going to stick with fractions. Let's go on to that next one. Combining my x's, that gives me -2. Combining my numbers, that gives me 46. I'm going to subtract my 46. Divide by -2, I get 22. Subtract my x's, combine my numbers. Subtract my 13, I get -8. So for these ones, a lot of times you have to use your distributive property, which remember is a multiplication property. So here I'm going to distribute my 2 and I'm going to multiply everything by that 2. So I get 5m plus 2m plus 2 equals 23. So now I'll combine my like terms, subtract my 2, and then divide by 7, so I get m equals 3 there. Here I'm going to distribute my 2. I have some like terms in the form of numbers to combine. Subtract my 8, divide by 8. All right, go ahead, try those last two, then check your answers. There we go. Same thing's still going to be true when we have variables on both sides. You want to get the variable on one side and then solve for your variable just like we were doing for all the other ones. So here I would subtract my 6m, subtract my 5, divide by 2. It's all the same processes. It's just you got an extra step. You have to get that variable together on the same side of the equal sign. So sometimes you can do a couple steps at one time. So here I'm going to subtract my 4c and I'm going to subtract my 5. 2 steps in one. We can do that. Then divide by our 4. Get my b's together, get my numbers together. So I get 2b equals -14. B equals -7. Again, with these linear equations, we should be able to get fluent, which means we're fast, can do them quickly. Add my 17p over, subtract my 19 over, divide by 4. Got to do some distributive here. Subtract my 6a over. distribute my 2. Subtract my 2 over, add my 7. H equals 3. We do have some special cases. We have cases that come up as identity, which means that there's an infinite amount of solutions. Or no solution, which is pretty self-explanatory. There's no solution to that one. So if we begin solving this, we do our distributive property. Oops, that should be a 6. If you notice, we have the exact same thing on both sides. 12x plus 6 equals 12x plus 6. This is an identity. So what that means is any number is the answer. You can plug in 6 and that'll work. You can plug in a 2, that'll work. You can plug in negative a million and that's going to end up working. It's an identity. Any number is the answer. Sometimes they say all real numbers also. Any one of those. So then for the next one, distribute my 5. It's not exactly the same, so I'm going to keep going. When I combine my ends, though, I end up with a 2 equals a 10, which is not true. 2 does not equal 10. So this would be no solution. No number is going to work when plugged in for that variable. Identity, any number works. No solution, no number works. All right, we'll go on to the last part. Kind of going over a little bit of linear equation or word problems here. We got a bookstore sold 18,000 paperbacks in 1 month. This was 10% less than the number of paperbacks the store sold the previous month. The following equation represents a situation where X represents the number of paperbacks sold the previous month. And so they give us the equation right there. So they give you the equation to work with. They want to know how many paperbacks did the store sell in both months combined. So if we start solving here, we're going to subtract our x's. So I get 0.9x equals 18,000. Divide by 0.9. And we're going to get 20,000. So choice A is our answer for that one. So is that actually our answer though? Nope. Miss Pelkey was rushing. Don't do that. Both months combined. This is just going to be month number 1. The second month, remember, they sold 18,000. So our true answer is actually going to be choice C. Don't make that mistake. Don't be like Mrs. Pelkey. Don't be rushing. Make sure you've always answered your question. So Mario needs to cut 3 bookshelves from a board that is 1.8 meters long. The second shelf is 15 centimeters longer than twice the length of the first shelf. The remaining shelf is 5 centimeters longer than the first shelf. The equation below represents this situation where X is the length of the first shelf in meters. So again, they gave us the equation. If you notice, they converted for us 15 centimeters would be 0.15 meters because this answer here was in meters. They had different units in here. So they had to take that into account, and they did. So they want to know the length of the first shelf, which would just simply be your X. So really all we have to do for this one is we just need to solve for X. So 1, 2, 3, 4, 4X plus 0.2 equals 1.8. Subtract my 0.2, divide by 4, and we get 0.4. So that first shelf was 0.4 meters. All right, next one tells us just simply to solve the equation. So we'll go ahead and solve. I'm going to distribute and then more distribute. So just like we were doing on the other ones, we're going to get our x's together. We'll combine these first into 46 though. So I'm going to bring actually this one over to here. So I'm going to subtract my 6, add my 4x. We get x equals negative 52. Shades are us, $20 per day to rent a lounge chair and $15 per day to rent an umbrella. Dan and Lisa paid a total of $245 to rent a lounge chair and an umbrella, each during their vacation. Lisa rented the chair and umbrella for 1 day less than Dan's. So here's Dan. These ones are Lisa. Together they paid $245. So they want to know what is the total amount Dan paid to rent the lounge chair and the umbrella during his vacation. So we need to first solve our equation. I'm going to do a little distributive. So 20x minus 20 plus 15x minus 15. Combining all of my x's, 20, 40 plus 30, 70x. Combine my numbers. Add my 35 over. That's going to give me 280. Divide by 70 and I get 4. But that's not how much he paid. That just means he's rented it for 4 days. So if I do 20 times the 4 plus the 15 times the 4, that's going to give me 80 plus 60. So he paid 140. So again, that's an example where we had to go a little bit further with our answer to make sure that we actually got the correct one. And our last one here, Bill is planning to drive from his house to a baseball stadium and arrive in time for the beginning of the championship game. His arrival time depends on the traffic. If traffic is light, he will travel at an average speed of 50 miles per hour and arrive 1 hour early. If traffic is heavy, he will travel an average of 30 miles per hour. The equation below can be used to model this situation where t represents the drive time in hours. Okay. What is the distance in miles from Bill's house? Well, we got to first figure out t in order to figure out the distance from home. So I'm going to start solving. Okay, subtract my 50t over, so I have negative 20t. Divide by negative 20, and I get 2.5 equals t. Now, this isn't our answer. This is his time. It took him 2.5 hours is what this is saying. So if I plug that in, whether it be for the 30t or the 50 times t minus 1, it doesn't matter. That's going to end up giving me 75. So it's 75 miles. That's how far he is from the baseball stadium.